Hello, hi, how are you getting on? It's Kieran here from Ireland and the college. How are you getting on? Are you good? Are you able to hear me okay?
Yeah,
One,
okay.
two,
I
three.
can hear you.
Think your mic might be on mute. So we'll
We'll
just give
just give
people there
people
a
there a
couple of
couple
more
more
seconds
seconds
just to
just to
join
join
us.
us.
We
We
might
might
have
have
hopefully a
hopefully
few
a few
more
more
participants with
participants
us
with us
today.
today.
I think
I think
last
last
week we
week we
only
only
had
had
was
was
just
just
yourself that
yourself
was
that
in
was
the
in the
group.
group.
Oh no,
And
last
I
week
think
I
you
was
might
in
be
Might
on
be on
mute.
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 Let me
Let me
just
just
there.
there.
Just need
You
to
need to
unmute
unmute
yourself.
yourself.
So
So
I'll
I'll
give you a
give you a
second
second
there
there
anyway,
anyway,
and
and
we
we
can
can
see
see
how
how
we
we
get
get
on.
on.
Hopefully, we'll
Hopefully,
have a
we'll have a
couple of
couple of
more
more
buddies in
buddies
the
in the
class with
class
us
with us
today.
today.
So we're
So
going
we're
to
going to
continue on
continue
our
on our
lesson
lesson
one in
one in
your
your
networking.
networking.
So
So
it's
it's
just
just
4 o'clock, so
4 o'clock,
we
so we
might have
might
one
have
or
one
two
or two
more
more
people
people
join us.
joining us.
So
So
we'll give
we'll
them
give
a
them a
second.
second.
Okay,
Okay,
so
so
back to
back
you
to
in
you in
one.
one.
Okay,
Okay,
so
so
we'll
we'll
just
just
give
give
people
people
there a
there a
couple of
couple of
seconds and
seconds
we'll
and we'll
get
get
going with
going
it.
with it.
So
So
today
today
what we're
what we're
going to
going to
look
look
at
at
is
is
some
some
of
of
the
the
networking
networking
terminology
terminology
that we
that we
use.
use.
And
And
we're
we're
going
going
to
to
look
look
at
at
the
the
topologies,
topologies.
okay?
Okay,
So the
so the
topologies
topologies
are
are
quite
quite
important from
important
the
from the
point of
point
view
of
that
view
we
that
can
we can
identify how
identify
the
how the
network is
network is
being
being
put
put
together.
together.
So
So
just
just
there
there
on
on
the
the
PDF
PDF
document
document
on
on
number
number
5
5
or
or
page
page
5,
5,
what I
what I
will
will
do
do
there, give
there,
me
give me
one
one
second, I'll
second, I'll
share out
share out
that
that
PDF
PDF.
so
So
you
you
have
have
a
a
copy and
copy
you
and you
can
can
see
see
where
where
I
I
am
am
going with
going
it.
with it.
But
But
it's
it's
also
also
available
available
up
up
on
on
the
the
eCollege
e-college
portal
portal
anyway.
anyway.
So
So
just give
just
me
give me
one
one
second there
second
and I'll
there
just
and I
pull
just pull
this
this
down.
down.
Excuse me.
Excuse me.
So I
So
think
I
it's
think it's
just
just
down
down
here.
here.
There we
There
go.
we go.
So
So
that's
that's
available
available
there in the
there in the
chat.
chat.
Are you
Are you
able to
able to
check to
check to
see,
see, have you
can you
can you
download
download
that
that
PDF there
PDF
that
there
I've
that I've
just
just
uploaded?
uploaded?
Okay.
Okay.
So
So
were you
were
able
you
to
able to
get
get
that
that
PDF
PDF
in the
in the
chat?
chat?
Are you
Are
able
you
to
able to
hear
hear
me?
me?
I
I
just
just
can't
can't
hear
hear
you, and I
you, and I
need to
need
be
to be
able
able
to
to
hear you.
hear you.
Is
Is
your
your
mic is
mic is
on
on
mute? I'm
mute? I'm
afraid.
afraid.
Okay, so what we have here is our basic star topology. And our star topology would be where we have devices all connected back into a central point. In this case, the diagram says a hub. But hubs are very old school. We don't use hubs anymore because they're noisy devices. We use a switch instead. Now, as you read through the documentation, you'll see there's two different types of switches. One of them is a managed switch, and the other is a non-managed switch. So some people will refer to them as layer 2 and layer 3 devices. But for this illustration here, you will see we've got a hub, we've got a server, a laptop, an Apple Mac, and we've got a PC. And they're all plugged in and connected to a hub. All right? Now, you might say to yourself, well, I use the network, but I don't use a hub. Because what you've got is you've got this thing called a router. And the router, actually, on the rear of the router, it actually has a hub or a switch on it. Now, I've got an example of an ASUS router here. Okay. So what we have on the rear of the routers, we've got our yellow ports. So our yellow ports allow us to plug in some network devices. We could plug a laptop, a server, and a PC into these individual yellow ports. The blue port is usually on these routers for connecting to the internet feed, be it the fiber or the telephone line. But the thing is that there's no actual standard. There's no standard to say the LAN always goes into the yellow and the network goes into the blue, because in some cases you might see it the opposite way around. Okay? So it'll be interesting. Sometimes we use wireless technology as well. Okay? And wireless technology is just another means of connecting to the network with a cable, except we're wireless. Okay? So what we've got there is we need to be able to look at the whole area of how the topology is put together. Now, with this topology, where we've got the router, which has a built-in hub in it, that is the main brain behind the system with regards to how everything is connected. If the router fails, or if the router breaks or anything, or just stops working, nothing can communicate. With the area of expandability, okay, we need to expand a network and add new devices, more devices to the network. It's very easy. We can just go just plug them in. Just plug them in and see what can happen. You know, what can happen there. And so the topology is very expandable. All right. So we can just add more devices to the network as we need to.
Hello. Did you unmute me? Hello, sir. May I talk to you?
Oh, I can hear you now. What's after happening?
Oh, no, it was a mute by default.
Very good. Excellent. It's always good when we can hear somebody because when you can come back and say, yeah, I understand that, or no, I can't understand it, at least you're good to go. You know? So yeah, it's always good. So how's your day been? Is it been good?
Yeah, it's good.
Yeah, all good stuff. And what part of the country were you located?
I came from Bangladesh, by nationality Bangladesh, and I arrived in 2022 in Ireland. And still I have an experience in networking sector. Although in country has been called is data center, but in my country it has been called ISP. No, I'm still not working over the 10 years plus.
Oh, very good. Excellent. Cool
but
stuff.
I don't have any formal certificate. That's why I'm interested learning and career in this field.
Okay. All right. Okay. So, are you familiar with networking?
Yes, I'm familiar with it.
Okay, very good. So the topology, so you're probably good with that. You know what the topologies are.
Yeah, I know very well.
Okay, brilliant. Now, another type of topology that we have here is what we refer to as the bus topology. Now, the bus topology is very old school, right? And the bus topology would be where you basically have a core cable, right? And you're going to have individual computers and workstations hanging off that bus topology. Okay? It's not really used anymore, but it does sometimes come up in an exam environment. And it's a very old kind of a system. And what you would find with the bus topology is the weaknesses and the dependencies. So usually with the bus topology, it was this is very old, right? It's kind of like it's older than me and you together. And so there was a terminator there, and there was a terminator over here. And this would have been used to make this network work would be we were using coax cable, right? So it was kind of we weren't using Ethernet, it was coax cable. Now the coax cable was linking PC to PC, so you had PC1, PC2, PC3, you get the ID, PC4, and over here you might have PC11, PC12. So what would connect these together would be you had your network card. So you have your network card that's plugged into the back of the computer, and from that you had a T connector. And the T connector used a B and C connector. All right? And what happened then was there was like two cables going to each computer. It was a bit like Christmas tree lights, okay? And the huge problem was that if there was a break in the cable, nothing worked. The whole network stopped. Okay?
Yeah.
So no, it was very slow. Usually this network might be working at what we refer to as a 10 base T network. So it was like 10 megs per second. It was quite slow. But think back 30 years ago, a network that worked by 10 megs was absolutely brilliant.
We are not familiar with this your PC terminal service. This type of service I have seen back my country as a dish supplier.
Okay.
Yeah, you know the dish supply, cable TV.
No.
Is random before previous time internet arrived back to my country. We used to the satellite television.
Okay.
That time used to be the coax cable and T. There will be multiple connection from one connection to more than 100 plus.
Oh, okay. Because this old sort of connection was, let me just go back here to Google. It was probably something similar to what was being used for TVs, was B&C connectors, or B&C connector LAN card. Okay?
Yeah.
So it'll kind of give you an idea of what this was about. So of course, a lot of this coaxial cable is still being used in the areas of CCTV, but this would be a typical example of the network card. And you had your B&C coax cable that connected to it, and it was like a T connector that was used, I suppose, like this guy. And you had the cable went in one side, connected, terminated, went out the other side, and then linked onto the next computer, the next computer, the next computer. Now, you had an element of, at the very end, the computer at the end of the line had to have one of these taps or a terminator at the end of the connector. And once that was terminated, that's kind of applied an element of resilience on the cable and the network worked. And if those terminators failed or anything, the network would go down. Now, the cable was very kind of finicky because if the cable broke or cracked, okay, the whole network was not going to work. Now, the follow-on or the more up-to-date version of that was people invested on Ethernet. So it was like the telephone cable using RJ40,
RJ45.
45 connectors, yeah. And it worked extremely well, you know. But this was very old school, the coax cable. It was something similar that was kind of used, as you said, for the likes of cable TV. But the cable TV used a similar type of coax cable, but it actually used a net connector. Okay, so what you found was the connector was a little bit different, but these are the connectors that are being used by cable TV providers like Virgin Media and so on. So there is an element of that out there, and it's an element that they're very, very similar as well. Now, with this bus topology, just remember that this is the bus topology. Okay. So what happened was this it was like the bus. Okay. So the bus could be in one part of Dublin. Okay. And then it kind of travels back and forth. Okay. And that's kind of like how it worked. Okay. And the traffic now was very, very slow. Okay, the bus topology. But if we think back 30 years ago when you had no Facebook, you had no Twitter or TikTok, so you weren't going to be sending a huge amount of data. It was actually super fast. Now it was noisy and it was slow. And it was noisy because if this computer wanted to send something to this computer, everybody knew about it. Okay? Because the bus went along and it says, does it go here? No. So it has to come back. Then does it go down here? Okay. So you can see where I'm going here with the route. It just went all over the place. And it was just like, wow. And then suddenly this computer says, yeah, it's me. And that's it. And then the bus would just stay here until somebody else shouted out, I want to send this computer wants to send something to this computer, so the bus traveled back, and then it kind of went back up again. So it was really slow.
Now, that time it always loop back.
Sorry?
That would be loop back. Return the data that will make the travel especially loop back, and they make no connection anymore.
Yeah. So it wasn't really fast, okay? Now, if there was a break in the network, somebody broke a cable, right? The whole thing stopped working.
Yeah, absolutely.
Okay. Yeah. And if we needed another computer plugged in here, so we need to add another device down here, okay? Everything had to be turned off. Then we need to get another computer down here. Okay, so that could be PC12 or 13, for example. And so it wasn't user-friendly, it wasn't easy to upgrade it. It was kind of not great. Okay, so the best thing to do then is that we start using this bus topology. So what we're going to have, like what we have in the diagram, we have our switch. Now, if we look at the hub, first of all, which looks like a switch, okay? And we've got a PC here, PC here, PC here. This is another PC, and that's another PC. Okay? And we're going to connect all of these to the switch. Okay? And we're going to connect this in here as well. And look, we'll find another port there for that one. So this is going to be a hub. So if this PC wants to talk to this PC, what happens is the information goes into the hub, and then it comes out over all of these at the same time. So it's a broadcast to all. Okay? So this PC says, yes, it's for me. Okay? I'm the person that's waiting for that information. But everybody else on the network, this knows about it. this knows about it, that knows about the traffic as well. So there's a lot of unnecessary traffic. Okay? So a switch causes a huge amount of unnecessary, a hub causes a huge amount of unnecessary traffic. So it's not good. Right? It's noisy, it's slow. Sometimes the network might have a collision. So when there's a collision on the network, a bit like the motorway, the traffic stops. Sometimes it may restart after a couple of seconds, but in some cases you might have to turn everything off and turn everything on again. Okay? For that to work.
Yeah, sometimes due to a hang issue.
Yeah, it can be. Now, the switch is different, right? A switch works very different to the hub, right? And what we see back here in the switch side of it, okay? So we've got switch to switch to switch to switch to switch. What happens is the switch learns the MAC address of the device. Okay? So in the switch is a little mini computer, and everything that's plugged into the network ports, it learns the MAC address. Okay? So the MAC address is unique to every network card, as we know. Okay? And then what happens is once that MAC address is learned and discovered, the switch knows the route to the device. So the switch up here learns all the MAC addresses of this computer, the server, this computer. It learns all of these devices, and it learns all of these devices. Okay? So if I want to send some information from this computer to this computer, the switch up here knows the MAC address of both devices, and it will send the information directly to it. So it makes it much faster, okay? And also, what it will do is it's just genius. It's brilliant, okay? Because it minimizes the need for unnecessary traffic. Okay? So let me just go and grab this for a second. I'm going to bring it into Paint so I can draw on top of it. There we go. So what we've got is, let me just click down here. So the system learns the MAC address. Okay? So the system knows the MAC address of all the devices. So the MAC address of each
connectivity
host. Yeah. So we'll say down here it could be 00, 14 EF 1 E. It might have 49 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it might have B5. Okay? So the MAC address is always 12 characters. Alright? And over here, we've got the MAC address of this computer. So it's 0, 1, 45, AE, F2, 56. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we need another one. Right? So A, B. Alright? So what happens is when the information needs to go from this computer to this computer, the switch learns the MAC address. So we call this the MAC address table. So a MAC address table. So it is discovered, it puts it into the MAC address table along with this guy. Okay, so it's like a text file that's in there. And that refreshes every couple of seconds. Right? Because if you turn off your computer, you're no longer accessible. So it's removed from the table. And if you've got something that you turn back on, like your smart TV or your music or your PlayStation, once you connect to the network, the MAC address table updates. Okay? So that will update every few seconds. Now, so then the switch knows that, okay, we need to send information from here to here, and that's exactly what it does. And when it's doing that, this machine doesn't know anything. This doesn't know anything. And it's brilliant. They don't know what's going on because it's not involving them. It's this PC over here to this PC, and the switch has kind of made that connection. The hub that we have to layer on will send the requests out to everybody. So that's what makes us slow and noisy. Okay? So the switch is super fast, the hub is super slow. Okay? So it's just to be aware of that it's not ideal. Okay? Now, so what you will find is the topologies. You've got a star topology, and you've got a bus topology. Now, we have another topology that we're going to look at, okay? And this topology is called a mesh topology, right? So a mesh topology is really good because it's got what we call redundancy, right? So I'm going to draw in 4 computers, okay? So 4 computers here. And I'm going to it's a bit funny how it's actually connected, right? So we have this computer connects to this computer, that connects to this computer, thanks Sean, and then also connects to this computer. Are you okay so far?
Yeah, you are talking about the sharing network.
Then what would happen, once I know, this computer with another cable will connect to this computer, will connect to that computer, and will connect to this computer. So it sounds crazy. And then the next thing what we have is another network cable that will connect to this computer to this computer, this computer to that computer, and this computer to this computer. So it just looks like a right mess.
Fully messy.
Sorry?
It's fully messy. Cannot be connectivity properly. It will be reach the data but cannot reach. You will try to send the data.
Yeah. What you're finding with this is because the mesh topology gives us what we call redundancy. So if somebody breaks the cable here, somebody's broke that cable, right? And I'm actually going to go back there for a second. So this is PC2, PC1, PC3, PC4. So if PC4, okay, down here, wants to send information to PC3, and somebody broke the cable, okay, what can happen is using the mesh topology, the data could technically go to PC1 and come back to PC3. It would take a little bit longer, a couple of seconds, but we could do it. Or what we could do is we could go from PC4 to PC2, and then PC2 back to 3. So we can find an alternative way to transmit the data back and forth. Is that okay? Now, we often use mesh topology with Wi-Fi networks, okay? Or your mobile phone network. So if one of the telephone masts goes down, it'll go to the next telephone mast. Okay? So we would tend to use the mesh topology. Just to be aware for the exam. The mesh topology is the best because it's got the most redundancy. The downside of it is it's got a huge amount of cables involved. Okay? I'm just trying to find one up there. It might star topology, mesh topology. Okay? So if one of the cable breaks, they can still connect and communicate to each other through another means. So we'll take a break there for a couple of minutes, guys, and we'll come back again. So maybe take 5 minutes.
Okay, sure.
Thanks.
পিরিয়ডে বাজে আবার ফোন দিস। এখন তো বাংলাদেশ সময় হয়তো 11টার দিক দিয়ে ফোন দিস, 11টায় ফোন দিলে বাদে আমি তো পরে ধরতেছি। বাংলাদেশ সময় 11টাতে, রাত 11টাতে তারপর আমি কথা কথা বলেছি।
All right, back again. So what we've got there is the mesh topology. And the next one, then we've got the ring topology. The ring topology is what we often find as the backbone of the internet. And the ring topology is a bit like it's a bit like the whole area of the bus topology. And the bus topology is where the data goes back and forth and back and forth. But in this case, you have a ring set up. So what happens is that the data kind of goes round and round and round, travels around the ring network, and it basically makes connections as it needs. The ring topology is mainly used these days for maybe connecting various countries together, around the world, so it gives us greater connectivity. And also, it is funny enough very old school, right? It is still a very old an old type of topology, which is kind of frightening in many ways, right? But it is there. So we do use it, right? We don't use it for our normal everyday network. Okay, it's used more so for big, huge, more WAN type of networks. Okay, so it's mad. It's brilliant, but it's very old school. And a lot of these ring topologies now are put together using a fiber distributed DC interface is what's connected at the end of them. It's not like that there's going to be an Ethernet or an RJ45 or a BNC connector. It's totally different, right? So what we have is the whole area of fiber. The reason it goes much further, don't get point-to-point links with a fiber, you can go up to 170 kilometers apart with the right fiber. Compared to the limitations of Ethernet, you can't go no more than 100 meters. Okay? So that's typical.
Ethernet can up to 150, 160 meters, but fiber can up to 10 GB at any place. It depends on the module. This 10 GB module or normally called as the SFP. In my term, it's called SFP, but we used to say the module, 10 GB module, 1 GB module. We used to put on the MikroTik router, switch, and then distributed by Cat6 or Cat5 cable. And if put on the recently invented the OLT. Right now, everybody was a connectivity with the OLT. No need Ethernet port anymore. Only connectivity with the router to PON or GPON with connectivity with the Ethernet is a short distance. Is a shortcut.
If you're using single mode fiber, you can go up to 170 kilometers. You can. Multi-mode fiber is far less. So when you're doing things like the internet connectivity or an ISP, they use multi-mode fiber, so it will be much shorter distances. Is that okay? So
could you explain? But I am not familiar with this term. Could you explain that you can say 170 kilometers?
Yeah, no problems. If you're using single mode fiber cables, like there's fiber comes in multi-mode and single mode. Okay.
A multi-mode means is the core multi-core is 12, 48, 100, 08 is a core multi-core.
Say if you're using like a single core cable, right? And you set that up into single mode, so your transceivers on both sides of your device are in single mode. You can get up to 170 kilometers with the correct transceivers and the correct cable.
Yes, little bit confused. In my country, I have to practical experience. If I throw any data longer than 500 kilometers, north of 500 is too much. If I want, I will be able to send. I can wrap whole Bangladesh. If I want to send, if I send from my city Dhaka, and it will be sent at my end of the Bangladesh border, it could be possible with a single core fiber.
Okay. I can only hear you sometimes with the audio, right? But from what I can gather, what did you mention about 500 kilometers?
I say I'm confused regarding your single fiber core or multi-fiber core. Normally, we bought from a local market, 4 core, 8 core, 12 core, 48 core.
You're all just dropping out, I'm afraid.
Okay, sure.
So the distance for a single mode fiber. Okay. So your single mode fiber. Give it a second there. So your single mode fiber, depending on the type of cable, can go anything, okay, up to, right? It can go long haul capabilities up to about 200 kilometers.
Oh yeah, right now I have got it. This is not a fiber; it's the Cat 6.
The audio is all distorted and muffled.
This is not fiber; it's a cable. And if you say the fiber, it will be sent in by MC.
The ONT is it?
Yeah, you know the MC, micro
Latency.
MC media converter. Right now is not very.
I'm only picking up. Do you want to log out and log in again?
I sent text you.
Yeah, send some text, right? But there is two different flavors of fiber. There's single mode and multi-mode, right? Multi-mode does not go as far as single mode, but single mode with the correct modulators and transceivers, it can go up to 170 odd kilometers, okay? Compared to multi-mode fiber can go up into 2 kilometers. Media converters use to transfer data in one place. Yeah, they would be things like your you can use various different boxes. You could technically use a switch them as a media converter. You could use Ethernet to fiber converters. The distance will all depend on, okay? One second there. The distance usually depends on the transceiver that's plugged into these devices or the power of the transceiver. Okay? Some transceivers, they can go really long distance. Like I'll just give you an example there, right? So let's just go fiber transceiver. And when we look at some of the fiber transceivers, the transceivers have two kind of ratings. One is going to be the speed, okay, and two is going to be the distance, okay. So if I click here on, we'll just say we get.
Yeah, I tell you earlier time. You use the stuff. I will show you. SFP. Okay. I tell you earlier time is we used to say SFP, single panel mode. We used to send data for a long distance, and it depends on the SFP model. Someone is 10G, someone is 20G. It will be distance.
Yeah, the distance is going to depend on the power of the
module
transceiver.
This module. Yeah.
So you could get, for example, here, right? We can get a basic transceiver. Okay. There'll be nothing major about this. But if we read down into it, this would do 1 gig, right? But when we click into it to get the specs, it might only support 1.25 gig. But it might only be over maybe 50 meters or it might be over 100 meters. It depends on the power output of the transceiver itself.
Yeah, it has been used for short distance.
There's one there, 550 meters.
Yeah.
Okay. Now 550 meters. Both multimodal and single mode fiber will do a minimum of 500 meters. But if I wanted to get a fiber transceiver, that will do maybe 50 kilometers. Okay. So what I'm looking at here is something totally different, right? They're obviously a bigger type of transceiver. So let's click on this guy. So this is going to be a bit different from your 30 euro one to your 300 euro one. But when I drill down into it, okay, it may give me an option. I might say, right, distance on this is going to be much further, and that will be based on. You see there actually, this is going to go 80 kilometers. So that particular transceiver, once it's plugged into the switch or the router or whatever the termination unit is, it could be an ONT or it could be a GPON unit. Point to point, it will do 80 kilometers without having to put anything in between. All right?
Yeah.
So Yeah, because if we think about maybe fiber cables going across the Atlantic Ocean to America, there's going to have repeaters at every certain interval. So the interval could be, in this case, if we were to use a load of these type of transceivers, we could have 10 gig transmitting across the fiber, and then we would have to have a repeater or something at approximately every 80 kilometers. Okay.
Yes, same way. Bangladesh received their data from Singapore and United America and also India under the submarine through the fiber cable.
Yeah. It's amazing.
It's a hub. They will make a triangle connectivity.
Yeah. Absolutely. So once you remember for the exam, right, that the Ethernet is restricted to 100 meters, right? And fiber, it depends on the type of fiber, and also, I suppose, the limitations is going to be in regards to the transceivers that's transmitting it.
Yeah,
Usually,
it depends on the fully transmitter.
Yeah. Usually what we say is you can go up to 170 kilometers with the cable. At that stage, you probably will have to use repeaters. But of course, we have to take into account what's actually making the transmission for us, and that would be the transceiver that's plugged into the switch or the router or whatever unit you're going to use. Okay? So just keep that in mind. Now, the other thing just to watch out for as well, with regards to what we're covering here, is the cabling, right? The cabling is really important because you've got unshielded twisted pair and you have shielded twisted pair. So the unshielded twisted pair is what most people have connecting their network together, compared to shielded twisted pair will prevent things like noise and electromagnetic interference on the line. So if you've got a network in a very busy, noisy area, where there's a lot of electrical interference, like from motors or lighting or transformers or equipment, you might find that, you need to use shielded twisted pair. And shielded twisted pair cable, the cores of the cable, the pairs, are wrapped with a foil to protect them from interference. Okay? And the twist on the wire is actually really important because the twist on the cables contributes to the whole area of noise reduction. And so if you unravel the cables, unravel the cores unnecessary, you may introduce more noise and more interference into the line. So where the lines are, or where the wires are actually, or the cores are actually crossed into the term twisted pairs, they're twisted for a reason. So if you happen to unravel a lot of them, okay, if you're working on a patch panel, and you decide to unravel quite a lot of these cables because it's easier for you to work with. So I'm going to put down there crosstalk, okay, on daisy cables. So just to give you an idea. So you may get an exam question. Okay, so this would be a great example of crosstalk. You can see here. Okay, so all the cables are pulled apart, and you could be inducting noise into the mix. This would be another great example of crosstalk. Right, something like this. It's the worst thing that you can do when you're terminating data points. So what you need to do is to keep the outer insulation sleeve as close as possible to the terminating point. If you have it all unraveled like we have here, we can introduce crosstalk into the connector, into the network. So that could be an exam question. What is crosstalk? It's where cables are touching on the cable, so there's an element of induction there, and we don't want that. Okay? So the great thing with fiber, you don't have crosstalk in fiber. Okay? Because it's light compared to electrical energy. So just to be aware of that. Now, the other thing that's important with regards to the exam, is when we look at fiber technology, it's how the fiber is actually terminated. The type of connectors at the end of the fiber. Now, I just wanted to check to see is there any mention of the type A connectors on this chapter. I don't think there is. I don't think there's actually any mention of such a fiber in it. When I scroll down along, there really isn't anything mentioned on fiber. We've got topologies, we've got a switch, we've got just a little bit on the networking stuff. We also have a peer-to-peer network, just to remember what that is. And a peer-to-peer network is very old school, where you would have two devices talking to each other. Now, this could be two computers, for example. So we have a computer, okay, and we have a computer. Okay, so this is our computer. So it's PC1, PC2, and what we can do is we can get a data cable, an Ethernet cable, and connect the two of them together. So in order for them to connect and to talk and to send information back and forth, right, you need to have what's called a crossover cable. Okay. Now, I suppose today we don't really use crossover cables anymore because the systems auto-sense. They know there's two devices that are similar, and they just happen to just work. But from the exam point of view, you need to know that any two devices that are similar, you want to connect them together, you have to use a crossover cable. So if you're connecting two switches together, you're supposed to use a crossover cable. If you're using two routers together, it would be a crossover cable. If you're connecting two switches together, or two computers together, it's a crossover cable. Now, what is a crossover cable? Well, it's basically a network cable, okay, like a data cable, but each end is crimped or terminated different. So one end could be 568A, and the other could be 568B. So that would be technically a crossover cable. The wiring is different on both sides. However, in the real world, we don't use crossover cables anymore, except if you're using Cisco. Okay? So Cisco like to use crossover cables. But what we can do here is this would be what we call a peer-to-peer network. The problems with a peer-to-peer network is you can only ever have two devices. You can't have a third device. So where it seems very old school, right? What tends to happen is we still tend to use peer-to-peer in many applications, especially with wireless technology. So you might have there could be an office, okay, and we might have another office, okay. So this office is in one of the streets in Dublin. So we've got big offices, okay. So office, and we may have another office somewhere else in another part of the street, or somewhere that we can see each other. We can see all the offices. So look, there's loads of offices together, a ton of them. Okay? So these are office windows, just to kind of give you an idea, and you can see there's loads of them there. So what we might do is, there might be, let's say this is another office. So what we could do is we could use a wireless connection, what we call a point-to-point, and we could have the wireless connection talking to each other. So it's a point-to-point. It's a bit like using your headset to your computer for talking. Your headset is talking to the computer using Bluetooth. That's a point-to-point connection.
You are talking about the wireless connectivity or wireless talk?
It could be point-to-point wireless. It could be.
Wireless. Point-to-point, randomly we use the radio device to send the signal. Another one is the receiver. If I send from Limerick a signal to Dublin, Dublin will be received. Or Dublin could be sender, I will receive a data. No need of fiber connectivity, just through the air.
Your audio is very poor. I can only hear you.
Okay, I just tried to.
Yeah, you just put it into the chat there for me. Now, if we don't want to do wireless, right, maybe there's interference or it's a security concern, what we can do is we could get a fiber cable and put it from office 1, dig up the ground, and we could bring it to office 2. That would be technically also a peer-to-peer network. It does not have to be wireless. It could also be connecting two buildings together with a cable. Okay? So radio device point-to-point without fiber connection. Yeah, you could. It will not be as fast as having a wired connection, but it does. Like if you think about a lot of the communication with telephone masts is done point-to-point connections, where they don't have fiber up to the mast. But yeah, absolutely. So this could be fiber. Okay, or maybe in some cases the buildings were very close, right? You might have Ethernet, but they need to be very close because of the 100 meters. Okay. It might be just across the street. That could be it.
Yeah, it could be sent 100 kilometers away.
Yeah.
But there is a limitation of data capacity. It could be up to 700, 500 MB. And cannot be reached 800 MB. I'm telling that you cannot send 1 GB data through the radio device, but it has a limitation. It could be up to 700 or 800 MB.
Okay.
If the signal is good, as connection between the 100 kilometer away.
Yeah. Sounds interesting. Sounds really cool. Now, so that's our task for today, right? So what I would suggest is you'd probably be able to, because you've got some knowledge of the networking already, you could probably try to do the exam soon.
I need to take a hand note so that I can take a preparation.
Okay. All right. I've uploaded the PDF in here, so go through the materials and just have a look at it, and you can talk to Eileen and Thomas and try and book your exam in. But try and book it in when you can. Go through all the questions, but you seem to have some networking knowledge, so I think you might be okay.
I tell you earlier time that I have a practical basic knowledge, but I have don't have a formal education experience.
Okay. All right. So we'll see you next week.
Okay, hopefully. Have a good day.
Bye.